Hello viewers, welcome to the channel Amazing Civil Engineering Studies. Time to enter the world of civil engineering. Here we will learn about different concepts related to civil engineering. Please subscribe to the channel and press the bell icon for more new updates. In today's video we are going to discuss about transportation engineering, flexible and rigid pavement. Introduction. The designing of pavement is one of the challenging tasks in transportation engineering. Rigid pavement and flexibility pavement are the two types of road pavement design methods. The pavement surface should be durable and it can withstand the load acting from the wheel tires. Pavement or carriageway is that part of the road or highway which supports the wheel loads imposed on it from traffic moving over it. It ought to be strong enough to resist the stresses that are being developed as a result of traffic. Pavement should also be thick enough to distribute the external loads on the earthen subgrade so that subgrade can safely bear these external loads. The pavement consists of a few layers of pavement materials over a prepared soil subgrade. Pavement consists of one or more layers. A simple classification of layers as per Indian practice is shown in as per below figure. The surfacing is the topmost layer, which should be smooth, abrasion resistant, dustproof, and strong. The base course immediately below the surfacing is a medium to distribute the stress evenly. The sub-base course gives additional help in distributing the stress. Subgrade is the compacted earth below the sub-base course. Pavement should be even. It should have light reflecting materials for night visibility. The layer surfacing is the topmost layer, which should be smooth, abrasion resistant, dustproof, and strong. The base course immediately below the surfacing is the medium to distribute the stress evenly. Sub-base, the base course that gives additional help in distributing the stress. Subgrade is the compacted earth below the sub-base course. Pavement should be even. It should have light reflecting materials for night visibility. Based on location, materials of construction, a fund available, necessity, use, traffic volume. Roads are classified into different types of roads like earth road, gravel road, water-bound macadam, WBM, road, bituminous or blacktop road, and cement concrete road. Type of pavement. This is classified from the point of structural behavior as flexible pavement, rigid pavement, semi-rigid pavement, composite pavement, flexible pavement. Flexible pavements are such, which on the whole have minimal or low flexural strength and therefore are rather flexible at their structural action under the loads. The flexible pavement layers reflect this deformation of these lower layers onto the top layer of the layer. Therefore, if the lower layer of the pavement or soil subgrade is undulated, the flexible pavement surface also gets undulated. Flexible pavement consists of 4 components: subgrade, prepared road bed; sub-base course, base course, surface course. The flexible pavement layers transmit this vertical or compressive stresses to the lower layers by grain transfer through the points of contact at the granular structure. All compacted granular structure consisting of strong graded aggregate, interlocked aggregate structure with or without binder materials, can move the compressive stresses through a wider area, and so forms a good flexible pavement layer. Bituminous concrete is among the best flexible pavement layer materials. Other materials that fall under the group are all granular materials without a bituminous binder, granular base, and sub-base coarse materials such as the water-bound macadam, crushed gravel, aggregate, soil aggregate mixes, etc. The vertical compressive stress is maximum on the pavement surface directly under the wheel load and is equal to contact pressure under the wheels. Due to the ability to distribute the stress to large area in the shape of truncated cone, the stresses get decreased in the lower layer. As such, the flexible pavement may be constructed in a number of layers, and the top layer has to be strongest as the highest compressive stresses to be sustained by this layer. In addition to wear and tear, the lower layer have to take up only lesser magnitude of stress as there is no direct wearing action due to traffic loads. Therefore, inferior material with lower cast can be used in the lower layers. Rigid pavements. A rigid pavement is constructed from cement concrete or reinforced concrete slabs. Grouted concrete roads are in the category of semi-rigid pavements. The design of rigid pavement is based on providing a structural cement concrete slab of sufficient strength to resist the loads from traffic. The rigid pavement has rigidity and high modulus of elasticity to distribute the load over a relatively wide area of soil. Minor variations in subgrade strength have little influence on the structural capacity of a rigid pavement. In the design of a rigid pavement, the flexural strength of concrete is the major factor and not the strength of subgrade. Due to this property of pavement, when the subgrade deflects beneath the rigid pavement, the concrete slab is able to bridge over the localized failures and areas of inadequate support from subgrade because of slab action. The rigid pavement slab has tensile strength. Tensile stresses are developed due to the bending of the slab under a wheel load and temperature variations. The rigid pavement doesn't get deformed into the shape of the surface as it could bridge the minor variations of the lower layer. The cement-concrete pavement slab may very well serve as a wearing surface in addition to an effective base course. The rigid pavement structure is made up of cement slab that is concrete. Below that the granular base or sub-base course can be provided. The rigid pavements are often designed, along with the stresses are analyzed using the elastic theory and assuming the pavement within an elastic plate resting over a elastic or a viscous foundation. Advantages of rigid pavement. Rigid lasts much longer, that is 30+ years compared to 5 to 10 years of flexible pavements. In the long run it is about half the cost to install and maintain. But the initial costs are somewhat high. Rigid pavement has the ability to bridge small imperfections in the subgrade. Less maintenance cost and continuous traffic and flow. High efficiency in terms of functionality. Difference between flexible pavements and rigid pavements. Serial. No. Flexible pavement. Rigid pavement. 1. It consists of a series of layers with the highest quality materials at or near the surface of pavement. It consists of one layer Portland cement concrete slab or relatively high flexural strength. 2. It reflects the deformations of subgrade and subsequent layers on the surface. It is able to bridge over localized failures and area of inadequate support. 3. Its stability depends upon the aggregate interlock, particle friction, and cohesion. Its structural strength is provided by the pavement slab itself by its beam action. 4. Pavement design is greatly influenced by the subgrade strength. Flexural strength of concrete is a major factor for design. Serial. No. Flexible pavement. Rigid pavement. 5. It functions by a way of load distribution through the component layers. It distributes load over a wide area of subgrade because of its rigidity and high modulus of elasticity. 6. Temperature variations due to changing atmospheric conditions do not produce stresses in flexible pavements. Temperature changes induce heavy stresses in rigid pavements. 7. Flexible pavements have self-healing properties due to heavier wheel loads are recoverable due to some extent. Any excessive deformations occurring due to heavier wheel loads are not recoverable, i.e., settlements are permanent. Semi-rigid pavement. When bonded materials like the Pozzolanic concrete, lean cement concrete, or soil cement are used in the base course or sub-base course layer, the pavement layer has considerably higher flexural strength than the common flexible layers. However, these bonded materials do not possess as much flexural strength as the cement concrete pavements. Therefore, when this intermediate class of materials is used in the base or sub-base course layer of the pavements are either designed on experience, or by using a new design approach. These semi-rigid pavement materials have a low resistance to impact and abrasion and therefore are usually provided with flexible pavement surface course. Composite pavement. A composite pavement consists of multiple structurally significant layers of different heterogeneous compositions. A typical example is a brick-sandwiched concrete pavement. The top and bottom layers are of cement concrete, which sandwiches abric clay in the neutral axis zone. What are the advantages of flexible pavements over rigid pavements? Braking efficiency is better. Flexes under load, thus the negligible depression gives more opposing force. Again, the flexing gives less bounce, giving more grip on the road. Smoother ride. Against the bounce. Less wear maintenance to vehicle and fuel consumption. Less wear to the tire. Difference in hardness. Repairs are cheaper, requires less downtime and easier. Initial construction cost is less in medium to hard soils. Flexible pavements are quickly constructed and repaired, but rigid pavements distresses and may be harder, more expensive to repair. Generally, but not always, rigid pavements are considered more expensive to construct. Thank you for watching. For now, please subscribe, like, share and do not forget to press bell icon.